Saxon Math 7-6, lesson 117. Welcome to my world. Let's talk about mass and weight. We're going to get a little bit science-y today. And we're going to talk about the difference between mass and weight. They're very close, but they're not exactly the same. Mass means the amount of matter, right? Everything's made up of matter, gas, liquid, solid. And mass measures the amount of matter that is in a particular physical object. In the metric system, we use milligrams, grams, and kilograms to measure the weights of things, right? This is a relatively fine weight. Milligrams are quite small. Grams are in the middle. Kilograms are like equal to pounds, right? What we would measure, like your weight would be measured in pounds. And what's cool, again, about the metric system is that we have this great relationship between them. 1,000 milligrams equals 1 gram, and 1,000 grams equals 1 kilogram. Oh, so easy and sweet, right? Pounds and ounces are so freaky. Okay, now here's the difference between mass and weight. The mass of an object is the same on the Earth, on the moon, in orbit, on Jupiter, whatever. Mass is always the same. The difference, no matter where you are, I'll write that. Is this marker petering out on me? It appears to be. Now, weight, the concept of weight is it changes with changes in gravity. So, if you went to the moon, which is a smaller body, therefore it has less gravity, you would weigh less. That's why when the guys were on the moon, they could like jump all over and it was really, really cool. If you went to a much larger planet than ours, say Jupiter, you would have more gravity and you would weigh more. Your mass, however, would be the same. So the way I always remember this is that when we're on Earth, our mass is equal to our weight. But if we go to any other planet, then our weight varies, but our mass stays the same. I hope that is just as clear as mud to you now. And I'm already sad that marker is just not, he's not my friend anymore. I'll switch to this one. Okay, so this is kind of cool. I'll read it to you. When astronauts are in orbit, forces are balanced and the astronauts experience weightlessness. An astronaut who weighs 154 pounds on the Earth, which would be a pretty skinny astronaut, right? Weighs 0 pounds in weightless conditions. Although the weight of the astronaut has changed, his or her mass has not changed, okay? So weight changes, mass is always the same. There's your science lesson for today. In the US, we measure the weight of objects in ounces, pounds, or tons, right? And we know that 16 ounces equals 1 pound, and we know that 2,000 pounds equals 1 ton. Okay, so this is the metric numbers. This is the English set of numbers. We usually measure mass in metrics, and we usually measure weight in English. That's not always true, but it's kind of helpful. And then if you want to if you want to go from metrics to English or vice versa, we can link them because we can remember that 1 kilogram equals about 2.2 pounds. So that is our crossover rate, okay? So let's just play around with a few examples. There's only a couple. There's only two. Example 1, 117.1. 2 kilograms is how many grams? Okay, well, let's see. 2 kilograms, we've set up here that every 1 kilogram is 1,000 grams, so 2 kilograms would be 2,000. Okay, yay, that's right. So I'm referring to this and this information. This one we'll probably use in the next one, right? And then example 117.2, the only calculation, 9 pounds, 10 ounces, minus 7 pounds, 12 ounces. Okay, this is kind of like the problems we were doing the other day when we have weird units, right? And we have to think about what we're doing. 10 minus 12 doesn't work. So what we have to do is take one of these pounds and rewrite it in ounces so that we have a bigger number of ounces. So I'm going to cross this off. I'm going to make this an 8. Then I'm going to take 1 pound and I'm going to convert it to ounces. There are 16 ounces in 1 pound. So this is going to, I'm going to add 16 ounces. That's the 1 pound. So now I'm going to have 26. 26 minus 12 I can do. Now I have 14 ounces. And it'll just be 1 pound. Make sense? Again, these are problems where you have to think and convert units as you try to do the subtraction. And they're like the ones we did. All right. I'm just looking at the practice problems. Let me just show you. Half of a kilogram is how many grams? Okay, well, we know a kilogram is 1,000 grams, so you can find half of that. The mass of a liter of water is 1 kilogram. The mass of 2 liters of water, okay, so we have to think logically here, right? If the mass of this, if a liter of water is 1 kilogram, then 2 liters would be 2 kilograms, and then we convert kilograms to grams, which you know how to do. It's 1,000. Okay, here's an addition and a subtraction problem where we're converting the ounces. And this one's kind of cute. A half-ton pickup truck can haul a half-ton load. Half of a ton is how many pounds? So this whole thing about the pickup truck and the load, that's just a red herring. That doesn't really add or subtract from the problem. All you need to see is half of a ton is how many pounds? Well, there's 2,000 pounds in a ton, so you can figure that out. Okay, good job. Lesson 117. See you next time. Goodbye.